Thanks for having me, Juan, and thanks for all the attendees for coming and to learn more about UAS traffic management. It may be a new concept for many of you out there, so I'm probably going to not start at a deep level, but maybe more basic to give you an understanding. So my name is Kucera, and just a little bit about me. I'm head of strategic partnerships for OneSky. OneSky is a new company, but we're founded from AGI, Analytical Graphics, and we've been doing this work with UAS traffic management for about 5 years. My history goes back with the company AGI for about 17 years, doing modeling and simulation in the DoD space, looking at similar problems: communication, navigation, surveillance, mostly for defense applications. I am an aerospace engineer and a commercially rated pilot, live out of the DC area. So today, just with UTM, I wanted to talk about the challenge that we have incorporating drones into the airspace. Okay, so there's issues. We can't just fly them because we don't want to hit manned aircraft. We might not see things, other obstacles that are on the ground, and airspace considerations are different. So there's lots of issues that I want to talk to you about. And then I hope I give you some perspective on UTM if you know about it. If you don't know about it, I want to talk to you a little bit about cooperative traffic management system goals for UTM. So maybe that'll broaden your perspective if you've already heard about it, but the use of cooperative traffic management incorporates not just drones, but people that are really unserved by traditional ATM that we need to start thinking about as well. So my presentation will probably be about 20 minutes, and then we'll open up for Q&A. So the challenge here, and it was a good tee up from Juan, but there's a lot of flights happening annually, and we see many more drones flying in the US. Now, at the current time, people would say, well, how many people are using UTM? Nobody is using UTM because it's not mandated for use. We're not even flying many missions beyond visual line of sight without having waivers. So we're building this infrastructure because we need it to fly beyond visual line of sight safely. But it's a bit of a chicken egg. We have to have it before they fly. And we have to do things in a crawl, walk, run phase. So we're doing lots of testing. We're doing lots of work with the ANSPs to prototype systems and make sure that they work for the missions that we envision in the future. The issues are low-level airspace is complex. We're trying to fly UAS, small UAS, lower to the ground below 400 feet, where most of the manned air traffic isn't flying, but also the benefits of using that airspace are we can see closer, we can deliver things to the ground. We're really serving the ground population with drones, and so we have to get closer. But this causes problems because we have urban terrain, buildings that aren't mapped. The FAA knows where towers are over 200 feet, but below that, they're not requiring people to notify where those towers are. We don't have any flight patterns or rules like traditional aviation, where if I were to fly easterly headings on VFR in the US, it would be at odd altitudes, westerly headings, it would be even. So those are just basic rules that we use to kind of lower the risk of a collision. There's many other rules, but rules of the road for UAS are pretty much non-existent. Communication architectures. So in traditional ATM, we use VHF radios, but at lower altitudes, we have the benefit of using things like LTE for cellular communications, which traditionally you've been told, turn off your cell phone before you get into an aircraft. And the reason is it causes interference to ground users. So we have to figure out, well, how do we do that without causing interference? Traditional ATM has surveillance infrastructure, radar, ADS-B. Many of these were even developed before commercial aviation because we needed them for for border surveillance or even security purposes that they then changed to become more for safety use. So we're modifying the way we use surveillance, but we also need to think that maybe surveillance isn't there for us for this new UTM world. So commercial traffic patterns, vertiports, where are we going to put them? How do we ensure that there's a space at a vertiport when we want to land because we're on battery power and we can't fly forever? How does that cause traffic flow issues? Many, many other things that we need to think about. So low-level airspace is void of much traditional manned traffic, but it is also much more dangerous in terms of obstacles and infrastructure that has traditionally not served the airspace community. So that's really the challenge. And we need to think that ATM, traditional air traffic management, should adapt and change to meet the needs of the unmanned community. And these are 4 kind of buckets of where we think change should occur. The first one is ATM is unable to effectively monitor and track UAS aircraft. So the surveillance that's out there that currently sees manned air traffic sees them well at 3,000 feet or higher, but below that, it's challenged. You have obstacles that get in the way, and then you have other issues like aircraft that aren't participating. They just simply haven't equipped with transponders or ADS-B, which is a way that you can share your GPS position. So we have an infrastructure problem. We have a volume problem. If we're going to have millions of drones, which is a lot more than manned aircraft, and we rely on humans to do air traffic control, then that doesn't scale well. So we have to think about automation and how can automation assist air traffic control. We don't want to replace them, but we want to make it easier for them to do their job. Don't show them a drone that's just flying around, but show them a drone that might be impacting an airport or is kind of hanging out in a glide slope where an aircraft might be landing. So how do we bring automation into ATM in a way that helps ATC do their job? And UTM can handle most of the load for unmanned systems. The next one is the lower altitudes. We talked about that. ATM has a challenge in scaling down to lower altitudes. We've seen simple issues of just what datum you're using for altitude. So in satellite space, and you're using WGS84 datum. Traditionally, ATM has used MSL, mean sea level. And then on the ground, we have AGL. So many mapping applications are using AGL and understand terrain. So we have to think more about AGL when we're flying drones than traditional manned aviation that uses MSL. And so that requires us to have things like common models for terrain so that we avoid obstacles, but we also avoid other aircraft. And we're doing these altitude conversions correctly. So that's just one issue, but there's lots of issues at lower altitudes that we have to consider. And the last one is funding. So just thinking about the ways that ATM is traditionally funded through taxing flights and things like that through commercial air activity, but also what we do with that funding in UTM can serve ATM. We're talking about things that help low-level flight, but we're also talking about ways to automate activity that might make things more efficient in the future. And so those are the considerations, I think, for how ATM could adapt and change. This is just highlighting, the FAA's system and other systems out there in the world are similar. We have radar, you might have ADS-B installed, and you might have a radar scope. In the US, we have STARS, we have ERAM applications. Those are the programs they use in air traffic control to see where aircraft are and separate them. And this shows you at low level where we have, lots of gaps in radar and ADS-B. At higher levels, you'd see the entire US covered. And it would be similar for other countries. So if we're flying drones down low, we need another way to see them, to incorporate them into the airspace traffic management system. So we have UTM. UTM was started in about 2015. There was the first UTM convention. We attended and had a booth there. OneSky did. At the time, we were still AGI. The idea is that UTM is a system of systems. It's a federated architecture. It means that no one company is building UTM. There are many companies that come together and offer their data in a networked way. But fundamentally, UTM enhances safety and security by sharing track position and information about the flight, and if necessary, pilot details for law enforcement to understand who's flying and where they are. So it's a system of systems, not a single product. Nobody just builds UTM, they build a part of UTM and it becomes part of the network ecosystem. So it's also collaborative, right? We need to share information. Regulators have information, ANSPs have information about surveillance assets they own, but UTM would like to use that to make sure drones are separated from manned aircraft. There's weather providers out there. Weather is important for all aircraft, and we need to figure out how to incorporate weather into UTM. And then we need to ensure that because a pilot isn't in the vehicle, that we do risk management properly. We look at things like our ability to communicate, our ability to navigate safely and accurately, and our ability to survey the airspace and make sure we're not hitting anybody. So CNS and prediction of your CNS infrastructure is all part of UTM to make sure that the risk you're taking on by sending a drone away from you, beyond where you can see it and manage it with your own eyes, that it's safe to do that. So that's the idea of UTM. A couple slides on OneSky and kind of our vision in the UTM space. The name really tells it all. Our goal is that it's OneSky, and we were started from a space traffic management company, AGI, analytical graphics, and so our focus has always been on all levels of airspace, space, all the way down to ground where we have UAS, but then in the middle where we have ATM, air traffic management, and even other challenges like commercial space launch for launch vehicles that put things into space. So it's OneSky, but we treat it differently. We have different systems that manage vehicles at different parts of the airspace stack, and we want to integrate that together. We want to make it safe between all levels and integrated so that you can share information easily from one domain into another domain. So that's the vision, is to harmonize the sky and to make it easier to share information between domains. OneSky came from AGI, founded a few years ago, but started back in 2015. The benefit is bringing a lot of history, a lot of experience, and a lot of software that we can reuse to do analytics on things like comm navigation, surveillance, prediction, to know where drones are able to fly safely. There's some other companies that were created by AGI that are beneficial to us. CommSpock is a space traffic management company, and the framework on which CommSpock was built is very similar to what we need. Because in space, we're relying on satellite operators to share information about where their satellite is, similar to how we want to share information about where drones are in a networked way and not relying on our surveillance architecture. And then Cesium, so many of you may know Cesium on the mapping side, was started over a decade ago, and it is a company providing web-based 4D visualization, so 3D in time, really built to be dynamic in a web-based environment so that you could use it for operational applications where traditional globes at the time, like Google Earth, weren't really satisfying our needs. So Cesium allows you to do that. And They've also designed a standard for streaming 3D content called 3D tiles, and 3D tiles can be used to stream anything like airspace. It could stream clouds. It could stream buildings, any content that you want to see in your 3D window. And then OneSky uses that analytically, so we can predict where radar is blocked by a building or GPS accuracy is low because the buildings are blocking the satellite signals. So OneSky brings all that together into one application. And what we offer is modeling and simulation tools, so you can build ConOps for your UAS missions, see how UAS would solve your problems and what kind of infrastructure you might need to support that mission. We can build real-time operations applications. So if you have the need to see multiple drones in your view and manage the input from those drones through a process and exploitation system. So you take your data and you format it and you see it in a 3D application. So we can build operational applications. And then finally, what we're doing purely with UTM and how we plan to share information with ATM systems and incorporate drones into ATM and ensure safety. So those are the three sort of product paths that we have. Here's some applications that we've worked for UTM. So we started really with TCL, NASA TCL4 as a UTM service supplier. So TCL4 was a NASA effort to look at how you share information across many different UTM applications. After that, we worked in the FAA UPP2 program, where we used a standard developed by ASTM, a standards organization, that really formalized that interface and allowed us to share information across UTM in a standard way. And there's lots of other projects on here. Two other notable ones are the work we've done internationally in Singapore, where we were challenged to look at UTM and the issues of using UTM in urban environments where you have issues with communications and using cellular, but also high buildings that are blocking GPS and causing issues for navigation. And we've deployed operationally a UTM system with Swiss FOCA and SUSI. That project is enabling remote identification so that we can identify drones and the operators of those drones as a remote identification service provider. And if you have any questions on any of these, please reach out. I'd be happy to talk more about them. So here's a video of UTM. I'll just play it real quick. This is our UTM portal, showing how you can create dynamic fences, and then how those fences become restrictions maybe in your UTM environment. We have corridors that the drones are flying through. So those corridors are 40 volumes, and it's a requirement to stay inside those volumes as you fly. The volumes offer strategic deconfliction, so that no two drones would operate in the same volume at the same time. So we can plan for conflicts, to deconflict the airspace in advance of actually going out and flying. So you can see how you map various aircraft, you follow them in their 40 corridors, and you make sure that you're flying safely. So there it is. We built UTM, right? So it's fixed. That's not so true, because we have other problems. There's lots of people out there right now flying that are also not served by ATM. People like gliders or crop dusters, aircraft that don't have electronic systems, parachutists, hot air balloon powered parachutes, and helicopters that are flying emergency missions, and even launch vehicles. All these people that are flying either low level or through various airspace domains like the launch vehicle, they're not talking to ATC. They don't traditionally have transponders. How would a parachutist carry something like a transponder and tell people where he is? you might identify a drop zone as the only way to reduce the risk. So my goal is to try to figure out how do we incorporate these objects into air traffic management, or at least UTM, so we can avoid them. We need to know where they are. We're flying in their domain, in their low-level airspace. But since they're not within the ATM environment, we have to think about it differently. So that's what this slide is showing you. At the top, traditional ATM, we have transponders. Those transponders, their job is to show air traffic management where you are, share your GPS position if you have ADS-B. If you don't, you'll be picked up by radar, and it will share your squawk code. That code is there, 3571. So it identifies you to air traffic management on the right. That's the way it works, but that equipment, like I said, can't be used by everybody on the previous slide. So you're pretty much hidden from ATM. So I'd like to challenge people that maybe even know about UTM to think of UTM differently, as maybe a cooperative traffic management system, because the real difference is that we're trying to incorporate new people into the ATM system or into UTM directly, but not using traditional infrastructure. We're thinking about things like using cellular. So if you have a cell phone that has GPS, it's not too far off to think that you could share your GPS position with a UTM just by clicking a button, and we start to see you in our UTM system populated on the map. And that device could be carried by somebody jumping out of a plane, or a glider, or a hot air balloon. So we're thinking about how to cooperatively share our track information so that people can see us in the airspace. And we have tools now through standards efforts like ASTM to do that. So we have federated network systems that allow different UTM service suppliers to share information. This shows you how we do that through something called a DSS, which is a discovery and synchronization service. It allows people to understand who's out there in the airspace and how to make yourself discoverable, how to share track information. And so it's not just one system providing air traffic management or air traffic control, but it's a federated system of people that are sending information for the purpose of safety, because they want you to see them. They don't want you to hit them. So it's different. When you're building a system for safety, you build it from a concept of sharing and cooperation. If you're building a system like radar, in the beginning, we build it for security, and it's uncooperative. We can see you if you don't even have equipment. But I feel that because we're building UTM for safety, we can rely on cooperation, and this type of model will work well. Finally, I just wanted to put out, a futuristic approach to UTM. So this is years in the future, but what it could be in terms of air traffic management being radar and ADS-B. What if things moved more towards the cellular model, where cell phone towers that are already out there with lots of infrastructure, it's ubiquitous, could be used to host new sensors. ADS-B FLARM is used over in Europe for tracking gliders. You could host Wi-Fi and Bluetooth to pick up on remote ID information from a drone. You could host new weather sensors or acoustic sensors to track sound from drones. So there are many, many ways that you could do this. And it'll be interesting to hear more about John Damish's presentation about how you can merge the two if you have airborne information and the tools that they build, and merging those into ground-based detect and avoid to really have a true layered strategy for safety for drones. So I think that's my last slide. And I'd pose the question to you: what can UTM do for you? UTM being an ecosystem, how do you feel that you fit into that ecosystem? Oh, thank you. And I'll turn it back over to Jan. Let me go ahead and stop, or Juan, sorry. I'll stop sharing my display.
Thank you. Thank you. That was very informative. We have a couple of questions from the audience. Chris, the first one is do your system consider static objects, such as buildings for urban environment and line power transmission towers in country environment?
The data for urban environments is sometimes better known in some areas than others. I don't think that we have a true global model for that. So in Singapore, they have exquisite data. It's mapped every few years, and we were able to get access to that data and use it in our UTM system. In other areas, you may have to pay somebody to do a survey and capture the information. There's a word for modeling things to high fidelity. We call it digital twin. So where you're modeling that region to the highest fidelity that you can. And that also probably involves things like the infrastructure that you have available too. So right now we're building a digital twin for Dallas, for example, because there's a lot of activity in Dallas for flying drones or taxis. And we want to model radar, ADS-B, LTE, cellular, everything that we would need to support drone activity. I think the answer is, so it's probably yes or no, depending on where you are. But the question I'd ask back is, does knowing where all those buildings are meet the needs of safety? And one of the challenges is that if you go out and map an area, as soon as you're done mapping that area, the map is already old. And somebody can move a device, they can put in a new tower, and then we wouldn't see it. So it's really hard to, fly by a map. You also have to have onboard detection systems that allow you a little bit more tactical ability to be safe. So I think map is good for strategic, but I think having sensors on board or a procedure for how you're going to fly safely is also necessary.
Yeah, we've seen in the surveying land surveying community an increase in what we call extreme accuracy mapping requests for certain areas, and those are corridors. In order to fly a drone in certain corridors, you will need to have accuracy within less than an inch of some things, right? Towers, and especially the distribution lines. It's not a straight line between the towers. It forms a curve, a shape that needs to be mapped precisely if you want to use. So yeah, it's creating a brand new revenue stream for mapping companies. The second question is about real-time telemetry, and it says real-time telemetry depends on autopilot. How do you collect data from different autopilots?
I didn't do a good job at explaining that. Yeah, so the autopilots on board aircraft are controlled from ground control systems, and some ground control systems look very simple, and some can be very complex. You could think of a Wing or Amazon operating fleets of drones. They don't have one system for each aircraft. They have one system that monitors all those aircraft. But the data on board the aircraft is coming down to a ground control system, and that ground control system's job is to share the information with all the other UTM service suppliers on a UTM network. So they do that by sending track position messages through a network to us. It could be a terrestrial network. And then we capture that information and share it with other operators that we're not serving directly, so that everybody has a full airspace picture to promote safety. I hope that, yeah. Finally,
before we introduce John, how do you envision the interaction between UTM and ATC originally? I mean, at the beginning, when we first deploy, because you mentioned in your presentation something about ATC should not be notified a drone that is 10 miles away from an airport, but something that is close to the airport. So in 2 minutes, how do you envision that interaction?
Yeah, I mean, early on when we started working UTM, this was pushed off to industry. It was something where ATC said, I don't want to see drones. They're not in controlled airspace. It's not my problem. But drones suddenly want to fly in air traffic controlled airspace. So we invent systems like Lance in the US where you can get an authorization to fly, but you have to fly under certain altitudes where ATC collaboration has showed that, we're not going to fly anybody below 300 feet. So go ahead and fly there. We separate you by segregating you. And I think as missions become more complex, we can't segregate anymore. We have to integrate. So we have to start thinking about how you share information, but you want to do it in a way that you're helping and not harming. If you have 100 dots on the screen, it's hard to manage that for ATC. You want to show only the things that become problems for them. And so I think we're just starting to get to that point where we're thinking about what does ATC want to see. Some of the programs we're working with the FAA and NextGen are looking at how to incorporate drones flying instrument flight plans, but still integrated in the airspace and under ATC control in some cases. And what technologies do we need? What gaps do we have? So I think it's a learning process, but we're starting to figure out that it needs to be more segregated now, and what systems need to be in place and what rules need to be in place for how you share information.
Okay. Yeah, I see as a pilot interested in preserving the safety of our skies, I would like to see interaction between the two systems, even if it's, on a side, but the ability of the air traffic control to consult a system and ask questions digitally.
Yeah, digitally is the most important thing. And as a pilot, we both know when we get up into the air and we're flying around and you're talking on your radio, how many times you step on other people when you're flying because you don't know when they're going to transmit. We could both push the button at the same time, and it causes so many inefficiencies. There's other inefficiencies, like if you're requesting a clearance, I want to fly from A to B to C to D, and then they want you to read back the entire clearance so that you understand, or they think that you understand it. So that causes too much time on the radio, and there's only so many people you can serve that way. But if you were to be sending a digital text message that says, here's your clearance, acknowledge, and you click a button, you just saved a lot of time on the radio for other things.
Yep.
So, I think UTM can bring efficiencies to ATM in that way. If we can enhance things like digital data sharing, what they call datacom in the US, then I think it helps ATM as well. So I'm really encouraged to see how, the UTM systems enhance the ATM over time.
Yeah, we'll talk about that in the panel discussion. Okay, Chris, thank you very much.
Thank you, Juan.